Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over difference of squares with leading coefficient 1. So, difference of squares comes up when we've got two different terms that are perfect squares that are subtracted from each other. So in this little general form that we've got here, a squared minus b squared can be factored into a plus b and a minus b. So anytime we've got two perfect squares subtracted from each other, we just take the square root of them and fill them into this general form. So starting out with example 1, we've got x squared minus 4. So both of these terms are perfect squares, so let's take their square roots. So the square root of x squared is just x, and the square root of 4 is 2. So we can take these two numbers, or these two terms, and fill them into this a plus b, a minus b form. So first we'll take that x, add the 2, and then our second one will be x minus 2. And this is that final factorization of example 1. So moving on to example 2, we've got y squared minus 25. Where y squared and 25 are both perfect squares. So just like the last example, we'll square root both of these and get y, and the square root of 25 is 5. So again, these will be our two terms that we want to use for the general form. So our first one will be y plus 5, and our second one will be y minus 5. So now, example 3, it's a little bit more tricky with this one, because instead of a squared in the top here, we've got x to the 4th. Now, in reality, x to the 4th is a perfect square. So the square root of x to the 4th is really going to be x to the 4th divided by 2, or x squared. So x to the 4th will split up into x squared times x squared. And then 16 itself is a perfect square, so the square root of 16 is just 4. So for this one, we'll have x squared and 4. So we'll fill that into that general form, x squared plus 4 and x squared minus 4. Now with this one we're not quite done yet, because if you pay close attention, this second term is another difference of squares, because x squared is a perfect square and 4 is a perfect square. Now we already found this one in example 1, but we'll just go over it again for the sake of this problem. So first, this one will just be brought down because it's a plus. Difference of squares can only be used when we're subtracting stuff, so this one we can't factor out anymore. So we'll have x squared plus 4, just leave that. Now, to factor this one out, we'll have our square root of x squared is equal to x, and our square root of 4 is equal to 2. So these two terms, plug that into the general form again, so we get x plus 2 and x minus 2. So this is our final answer for example 3. And that's it for the example problems. So with difference of squares, just make sure that both of your terms are perfect squares before you start, and that both terms are subtracted from each other, because those are the two requirements that we need to pass to factor by difference of squares. That's about it. Thank you for watching.